This stuff here is going to build off of what we've been doing the past few days here. But instead of having to go through and do the scatter plot and coming up with our own equations, they kind of give us some information to help us set up the equations, and we don't have to pull it from a scatter plot. So we got two different options here. We can have combined variation or joint variation, and the difference between the two, the combined variation, and I would, if you didn't underline it or highlight it, I would. So the combined variation, you're going to have both direct and inverse variations. Okay, so you're going to have some direct stuff and they'll tell you what's direct, and you're also going to have some inverse stuff and they'll tell you what's inverse, but both of them are going to be in the same formula. Okay, and then as we know, direct goes on top with the k, the inverse stuff goes on the bottom, and then they kind of give you an example there. I think that's the one that we might even had from the assignment yesterday, where you had your m's equal to, the stuff on top there with the k is direct, the d on the bottom is the distance. Okay, now with our joint variation, and again, hopefully you got it underlined or highlighted or whatever, all of our stuff is direct variation. So in these cases, they'll just say, hey, they vary jointly. If it says that it's a joint variation or they vary jointly, that just means everything is on top with the k value and everything is direct. Okay. Our plugging in and finding the k's is exactly the same. You get the information that they give you, plug it in, solve for the k. Only difference here when we do solve for our k, because there's a lot of variables that we're going to be putting in there, sometimes we're going to get a real gross number for our k value. Instead of trying to round that and then doing math with the rounded button, what you're going to do is you're just going to leave it in your calculator and then use the ANS button, which is the answer button. That's going to give you a much more accurate answer, and I'll show you how to do that as we do some of these, okay? Okay, so the rest, like I said, should be in your example packet, so just grab those. So for example 1, it says the hyperfocal length h in yards varies directly with the square of the focal length L in inches and inversely as the selected aperture f. Okay, I think this has to do with like photography and like taking pictures and like zooming in and out and focusing and that kind of thing. Pretty sure that's what it is. So it says write a general variation equation to model this situation. Okay, so it says there we've got that h value varies directly as the square of that focal length L. So I'd start with that. So we would have that our h varies directly as the square of that focal length L. So L squared, and that's on top with the k. And then it says it also varies inversely as the aperture f. So inversely would mean it's on the bottom, right? And they just say f, they don't say f squared or anything like that. So that would be our general equation for that before we do any solving. Okay, so then it says find the value of k when our hyperfocal length is the 1.75, so that would be our L, and then 12 yards. What's the 12 yards then? Hyperfocal length, oh, hyperfocal length is the h, sorry. That's h. The yards is our length. And then the aperture is f for the focus. Okay, so then I'm just going to take those pieces of information, put them into my general formula there. So my h would be 1.75. Actually, do I have those right? Hyperfocal length of...
Well, for the person it says length L in inches.
Yeah, I think I got those backwards.
It says 12 yards.
Yeah, I think I was doing it right the first time. Agreed, because it says, yeah, it says yards up there and inches right there. Yeah, that was a good catch. Sorry. Okay, so now we got our h in there. I hate when they use like things that I don't know about, like I don't know what hyperfocal length is. That gets confusing for me. Okay, so the 12's going in for the h. So 12 is equal to k. Now our length is that 1.75 squared over, and then our f is 9. And then they want us to solve that for k, so what would you probably do there to start to solve for k? Well, you could do that. I would probably actually get rid of the 9 first. How do you get rid of divide by 9? Multiply by 9. And I'm just doing that because otherwise that's just going to be a longer decimal number when we square it. So instead of just rewriting that, I'm just going to leave that for now and get rid of the 9 first. 9 times 12 is 108 is equal to our k times the 1.75 squared. And then you could either, there's two ways you could do this. You could either figure this out now, and we could have figured it out on the last step, I guess. That would have been fine too. We can either figure it out now, or we can just get rid of it as a whole chunk. So if you were thinking about getting rid of it as a whole chunk, when the k and that right there are right next to each other, what does that mean? Multiply. And how do we get rid of multiply? Divide. And again, you could have turned that into like 3 point something too if you wanted to, but I'm going to divide by that on each side. Because now when I do it out for k, because that's all gone, I can just type this all into my calculator in one step and not have to round it all. So I would just do, and again, you don't have to do it like this. You can do it like on my sheet from before. I did it where I actually figured out what it was and put in that 3.0625 in there. That's fine too. But I would type into my calculator 108 divided by, and then I'm going to go parentheses just to make sure it does that part first. It should based on order of operations anyway, but I put parentheses in there just in case. So that 1.75 to the power of 2. And then when we do that out, this is that gross number thing that I'm talking about, okay? Because if we look at that, is that a nice number to write? No, it is not. So this is that, if k is our gross number, leave it in our calculator. So I'm going to write this on my sheet so I have an answer to have to, if it was a test or whatever, to turn in. But I'm going to leave this in my calculator for my future calculations, okay? So I'm going to write it down now just so I have it. So our k is approximately equal to 35.3. And then they want us to take that for step C there. They want us to take that k, put it back up into the original one, which is actually way up there. So we're just taking it and putting it back into the original. So it would be h is equal to, again, we're just putting our rounded one in here so we have an answer on our sheet. So h is equal to that 35.3 L squared over f. But now they're going to ask us to do an actual calculation with that, and that's when I'm going to use the gross number for my calculator. So I'm going to set it up here first. So they've got h is equal to, okay, and they say we're supposed to find the hyperfocal length, that's why I put the h, in yards if you want to shoot a 12-inch lens, so that must be our L, and then our aperture setting is 2.5, that must be our F. Okay, so again, I'm putting that 35.3 in there just so I have something to write down for my formula, and then my L is going to be that 12. And that one's squared over my F is 2.5. And then this is where I'm going to keep that gross number. So we know here, if we're going to kind of do this out, wouldn't we take that gross number times 12 squared? What is 12 squared? 144. So I'm just going to take this gross number times 144. Again, get a gross number, but leave that in my calculator instead of rounding it. And then I'm just going to divide by 2.5 because that's the most accurate answer that I can get. Because if you round along the way, then your answer is just going to keep getting further and further away the more times you round. Does that make sense? So our answer here for this h would be approximately equal to, now I do my round, I do 2,031 point, I don't think it tells us what to round to. So let's go just 0.3 yards. So very similar to our stuff before, but instead of coming up with the equation from the scatter plot, they just give us the stuff and we just go from there. Okay, with me so far? Okay, one more example. All right, example 2. We got volume of a solid with a circular base varies jointly as the height of the solid and the square of the radius of the base. Write a general equation to model this situation. Okay, so what is it when it varies jointly? What's jointly? Yes, and they're all what?
Direct.
All direct, right? So even though they don't say direct, because they say jointly, that means everything is going to be on the top with the k. So our volume here would be equal to, always have that k in there for our variation problems. And then again, because it says jointly, all of these values here, so the height h and the square of the radius, that's all going on the top. So we'd have h, and then square of the radius would be like r squared. And again, it doesn't say directly, but if it says jointly, that means everything's direct. Okay, and then we just do our same thing we did before. They give us some stuff, and we're going to solve for K. So if volume of the solid is approximately 75.4, so that's volume. When the radius is 2 centimeters, so that's R, and the height is 6, that's H, we find our K value. So again, just taking our numbers and putting them in there. So 75.4 is equal to the K, which we don't know. Height is 6, and radius is 2. And just remembering our radius is squared. Okay, and then from there, what would we do first here, probably? Yeah, I would probably square that again. Like, you didn't have to, you could have done other stuff first, but in this case, since it's an easy one, what is 2 squared? 4. So we'd have like K times 6 times 4 is equal to our 75.4. And what is 6 times 4? 24. So we'll have K times 24 is equal to 75.4. Or you could have divided by 6 and then divided by 4. That's fine too. Because now to get rid of multiply by 24, we'll divide by 24. So we get that our K equals, and I think this one's also a gross number. So 75.4 divided by 24. Yeah, so it's kind of a gross number there. This one we could actually write what it exactly is because that 0.6 is repeating. So you could go 3.141, and then the 6 is straight up repeating. But again, I'm just going to leave it in my calculator to get the most accurate answer when I do my solving. So then from there, value of K is approximately equal to what famous mathematical value? What do we know that it is 3.14? Pi, right? Isn't this very similar to pi? Yeah, it would be. So that's supposed to be similar to pi. And then they say write the variation equation using your answer to part B. So here, instead of using this number, they want us to put a pi in there instead. So like volume's equal to pi times H times R squared. If you put that number in there, I'd be fine with that too, because it's kind of confusing here what they're asking for. But this is actually like an actual formula that you would use to find volume of something. Does anyone know what this formula matches with? It has to do with a circle, but think volume, so like 3D, not a sphere, that's 4/3 pi r squared. Cylinder, yeah, so cylinder because it's got the circle at the top, then you've got the height of the cylinder. But yeah, anytime you deal with circles, you have to have that pi in there, so that's a cylinder. I wouldn't ask you that on the test, but that's just the example that kind of comes with the book. But big thing is jointly is everything's direct, and then the solving out for K is the same as what we've done before. Okay, so that's your book page there, 133, 1 to 11.